So this should be on now? Perfect. Very nice. So hello everyone. Good morning. I might repeat now one or two things that Andrea already has prepared you for, but the first talk will be very different from yesterday. So we are not focused so much on results of what light exposure does or how the patterns look like, but more the idea is to give a little bit of a sneak peek into the processes that we are using in the lab in order to make the findings and the data that we collect accessible to people, so that people can actually go in and see for themselves whether the findings that we report actually exist or based on sound science, on sound analytic strategies, or if it's basically just a random number generator and we are claiming any kind of thing. So the idea is, again, to look at two examples from the projects that we showed data from yesterday, the Melidos project and the A Day in Daylight project. Quickly want to acknowledge the funder, he's here again. And so I think everyone here has been here for the talks yesterday, right? Is there someone here now? So, you know, just as a very brief explainer what the topic is going to be of the data, even though we are not interested in the analysis so much as in the context here, is personal light exposure, meaning collecting data as close to the eye as possible, because the amount of light that reaches our eye at certain times of day is important for our health. It keeps us active and alert and can suppress hormone production in the night, so we want to avoid light at night so that we can sleep well. We want to maximize light exposure during the day so that we are active, and this promotes better sleep at night and long-term health. And so we are interested in capturing light exposure patterns in the real world under naturalistic conditions, and this might look something like this. And the idea really is to take these patterns and look at them in terms of are there certain commonalities between people, or what are differences between sites, how often within a day do we cross certain thresholds of recommended light, for example, this person obviously crossed this threshold that you can see with a dashed line here, and so sometimes during the day this person was above the threshold, so in the zone where we recommend light exposure to be, but most of the time actually it was below that, and that is a very common pattern that we see. And so the idea really is about processing these kinds of data. Now, what you might find in the published literature very often is some findings get reported. You can read up on this in tables, in text, and in figures. And then at the end, there will be something like this, a data availability statement, where it says, well, you can't really look at the data, but if you ask nicely, we might give it to you. And so we believe this is not the right approach for the data that very often gets, you have funders that pay for it. Very often these fundings come from public money where the taxpayer basically spends the money for the data to get collected to. And if we restrict this access beyond the initial analysis, then really we are not making the most out of the data. There might be good reasons to restrict access for, if there are like personal sensitive information in there, that is obviously not a good thing that you want to publish, but very often with a little bit of effort you can anonymize these data so that you actually can share the underlying data without making available personal information that you can come back to an individual. And so just to put the publications that are out there when you search for a scientific publication into context, what you in almost all cases can see is like an abstract of a publication, like a little summary paragraph that tells you we did this, we found this, and this is why it's important. The underlying publication might be accessible. You might have to pay for it depending on who you publish with. It obviously contains a lot more information because people write up there analyses and show a little bit more about the methods that all of this is based on. So let's say you have a publication and it is open access, then you basically get a longer manuscript, a longer text, some figures, and some supplements that might explain secondary information about the published paper. And usually that is all that you're seeing. But this is really just the tip of an iceberg of how these results are actually generated. I'm not talking about data collection here. The data is collected. There is like a study protocol that has been followed. So you collect these data after a standardized protocol. And so basically what sits at the very heart here is you have collected the data, and in order to produce the results that you then publish, usually there's some analysis code necessary, and the results itself are not what is published. So the published literature is a summary, like a high-level summary of the actual results, because the results that you get when you apply the code to the data will be some modeling results and long tables where you have to extract what kind of information is actually useful for someone else to report. And that is not all. There is usually a part in between that is also very important, because how you pre-process the data before it gets actually analyzed fully is also very important, and this can make or break how sound a scientific analysis is. So this pre-processing might be part of the code. It could be something that you write up, but it also could be something where you actually edit some file in a text editor, and that editing gets then lost, basically. So like you don't have a record of it unless you record it specifically. So there is a pipeline here that you don't have access to that is very important in understanding how these results came to be. And I'm not saying that everyone that reads a publication should also read all of this, but I am saying that we should make an effort to make this accessible as possible. The thing is, just throwing this out there in the world will help nobody, because it will not be comprehensible usually. So giving access is like the first important step, but in many ways it has to be additionally made like useful and understandable, comprehensible. So just one more sentence about access. There has been a nice publication about this exact statement that I showed before. A researcher basically went out and looked for papers where it said, you can access these data upon request. So he requested the data, and what he found that only in 17% of cases were people actually sharing that data. So, in about 1 in 7 cases, you could say you can actually get the data. In other cases, there's just no response. This does not have to be malicious. It's not like someone is trying to hide this. It might simply be that this person is, not responding to those emails anymore. They might have moved on to a different field, and so all of these data that are like very useful for secondary analysis is then lost. So, there is a big reason, or many reasons, why we should make data and all the following processing steps available. As I said, like just accessing something does not mean it is actually useful. You have to comprehend it, and for that you have to annotate what you're producing in terms of pre-processing, in terms of code, in terms of results, so that someone else that looks at this, or yourself in 2 months, because you will forget the details of your analyses, can actually remember and understand what's happening there. And data in itself, this can be a heap of data that is in theory useful. If you don't know what the columns mean, what kind of variables are encoded in there, it really doesn't help you anything. So you require metadata, data about the data, to make this understandable, and usually the term that is used in that context is fair, meaning you have to be able to find these data and metadata in the first place, to be able to access them, interoperable, so you need to be able to operate with these data in different contexts and surroundings, and reusable, so in an ideal case, these data are licensed under a permissive license, so you are allowed to use these data for your analyses. Even having all of this doesn't necessarily get you to the top level, because you also usually need an environment where you execute all of this. Imagine I'm dumping a load of code on your laptop. If you don't have the right programming language, you will not be able to reproduce these results. So reproducibility relies very heavily on some environment, some common environment that allows execution and that facilitates reproduction. So someone else that does not have access to your knowledge about the analysis, should be able to recreate the exact results that you're producing. Otherwise, what you're producing is an artifact that is like heavily fragile. It only exists because you can make it to be. You're not producing it in a way that someone else can go in and can actually look at it. Now, if the underlying results are set up in such a way, you will have achieved a lot in terms of to make the context of any published paper a lot more comprehensible. And the idea here today is to talk a little bit about some of the tools that we are using to facilitate these layers. We will not go into details of all of them, but the idea is more to showcase like a very simple process and to demonstrate it in one or two examples. So one current project, the Global Light Commons that we are working on, is really about this data and metadata part. And so the idea is you're collecting all these data from all over the world, different sites, and ideally you can analyze them in a straightforward, standardized way. You don't want to learn all about the data anew when you go to a different site. And so if we really want to make meta-analyses possible, so in the future when there are many more data sets and not everyone is exactly following the same protocols, you still want to be able to draw some common conclusions using these data, and so they have to be formatted and annotated in a standardized way, and the Global Light Commons is basically a set of standards and validation toolkits that facilitate this formatting of the data. For external reproducibility, there are different methods. One that we like to use is code check, which is basically what I've talked about before, which is you hand over all of your code, all of your data to someone else and say, run this code. Does it get the same results on your end? So this person knows nothing about what you're doing. They just get a bunch of code and they have to be able to get to the same results. So this is a third-party project that is really very nice because they do this for free. It's a lot of work, and I think it is a very valuable contribution to scientific literature. Now, in terms of where the code and the data sit, two tools we are using is basically GitHub to host the repositories, the data, because it is free, it is accessible, and it is integrated very well with many different tools. If you don't know GitHub, it really is like an online server where you can create a repository that is accessible through an URL, and you can push data to it, and it has it traces all the changes. So every time you upload a new version of your data, it will trace those, and you can go back and see the versioning. And then Zenodo is a European archive that allows to long-term archive your information. So GitHub is something where you can go in and you can even delete a repository, so it will be gone, and it will be gone from the records. If you archive things on Zenodo, then they are part of the permanent record. So they will be available long-term, There are others out there where you can get a similar result. But the idea really is that you need some permanent archive, some permanent record about your data that even though your GitHub account might no longer exist, still is accessible. And at the heart of this execution of code and write-up of results are tools for data analysis and technical and scientific publishing. And so we today are going to have a look at these portions here. So the idea is to take a bunch of data, see how they are hosted, write them up and do like a very small analysis on them just to get a basic understanding for that. And the idea really is to make this as a seminar type. So I will sit on my computer and execute that. And you can either wait for the recording that it goes online and then do it in peace at home, or you can follow along here. You really don't have to install anything to follow along, so I've tried to use tools that are online. Well, I mean, for GitHub repositories, you can specify how you want to collaborate. So you can invite other people in. And at some point, if you really want to publish these, then they have to be online and like publicly visible anyways. So GitHub has basically two modes. You can either have private repositories that only you and your collaborators can access, or you have a public repository that anyone can access. And so for some of the tools that we are using here, we require public repositories, and those anyone can access. Maybe if there's time, we'll also make a quick check into Zenodo, but really the main idea here is to stay in this area to look at the underlying results here. So let's look at two examples. One from the Melidos field study. I presented some of the results yesterday, and actually all of these results are hosted online. So you can follow that QR code. And hopefully the internet connection here is working for me as well, so I'm waiting just a little bit so you can follow the QR if you want to. Here we go. So I need to end the presentation here. Here we go. So this should take you to a web page like this. So this is a page that is hosted by GitHub. It is available to everyone in the world, and it contains the write-up to the analysis and to the publication that right now is just out at a preprint, but it is under review at the journal. And so if you scroll down here, you will find this is I would say, nicely formatted way of the publication compared to what you see when you go to the preprint. So you don't have the link here, but the preprint, which is like the precursor to the official publication. If you download the PDF here, you will get basically a Word PDF, which is not very nicely formatted, and so you can read up, I think, in a much nicer way on a page that is hosted here. And so this is basically an HTML page produced by Quarto. And we're going to go into what that means a little bit later on, but for now it really is just a way that you can format your results, write them up in a nice way. And if you can see over here, there is a navigation menu, and there are some analysis scripts in here. So if we click on them, like for data preparation, you can see that this basically contains a mixture of just explanatory text, of some code cells, and also of output of code cells. So the results basically. So if we go down a little bit, so there's not a lot produced here, but let's see, for example, for the session info, so there's a code cell that executes one function that's called session info, and the result is then printed underneath and gives us the basically the executing environment. Maybe let's go to something a little bit more exciting here. So there are different research questions and hypotheses we are exploring, and so the analysis script really contains everything that goes into this. So our ideas as text, the code as code cells, and then the result from those code cells printed underneath. So someone can go in and can see, okay, what did they actually do? How did they get to the point where they were able to, let's see if we go down here. So how did this figure get produced that is part of the published record? And if you were to execute all of this code that leads to it, you would get the exact same figure. And so, I mean, this doesn't tell you whether you can reproduce it, but it is like a full trace beginning to end of how the results came to be. And they are documented in an accessible way. So everyone can go there, can look at this and can say, okay, you know, this might be right or not, depending on your level of knowledge to that. But you can also use it for learning. And actually, that's why I'm a big fan of this approach, because I'm coming from architecture. It's not a field that traditionally has a lot of coding in it. So when you have to do some data analysis, it is really great if people out there are sharing how they approach these analyses. And you know, share their thoughts about it, and I think that is a very great way to do that. So basically, these documents combine a narrative in form of text, code, and code results, and make the process of the result generation more transparent. Let's look at a second example for the A Day in Daylight project. Where is it? Here we go. So there is another QR code that you can follow, and it will take you to another page that is produced by Quarto. I'll give you a moment. And if you follow that, where is it? Then you should be dropped off in a page that looks like this. And there is one button here that tells you open the dashboard. And so on a phone, actually, I don't think it will look very nice because some of the figures get squished. But if you open it on a tablet or a PC, you will be dropped off somewhere like here. So in a little dashboard where you get some information about the data that was collected. And you have different tabs here that allow you to explore some of the collected data. So you have tables here. You have the option to explore small video snippets of data, like figures, tables, some of them even interactive, where you can just hover over and see some additional details about the data, and then many different tables that basically summarize how different contexts led to different outcomes in terms of personal light exposure across the time of day. And so this is, you know, this is one method where the data that you collect can really be presented to, you know, outside of a static PDF file that just contains text, where you might go in and explore a little bit how, you know, what the data looks like. So I might be focusing on one thing when I write up the data because I'm interested in that. That is my primary question. But someone else might come in and they are interested in something completely different. And giving access to these data is always easier if it's done in an accessible way and reproducible way. So there is an analysis script that is at the very top available here, and this is something that we already saw in the first script. So this again is a script beginning to end that tells you how all of these results that are presented in the dashboard actually come to be. And so you can see there's code, there's output that you get of code, and even though it is a very long script, if you're interested in something specific, like, oh, this figure was nice, how was it produced, what's the underlying data, did the person, like, you know, put some of the data out that he didn't like to show, or was he like straightforward and just showed all the data? All of this can be basically traced back if you look at all these script functions before that. Now obviously you have to be familiar with the script language underneath that, but I think like that's the case in all of data analysis, that there has to be some knowledge on that, and you can read up on that. In fact, in this case, you might notice that there are hyperlinks for each of these functions. So if you are interested, what does this function actually do, you can click on it and you will be led to the exact function documentation, what it does. So even though you might not be familiar with the function, you can read up on it. So the idea really being that the write-up of results should not be a part that ends and then you just put it in a folder and forget about it, but spend a little bit more time and put it in a place where other people can discover it. And obviously all of this is, you know, just a viewport into this. The actual underlying data that produces all of this is sitting in a GitHub repository. And so you might notice there are these links in here, and if you click on them, you are brought to the repository that's underneath, and this repository contains all the data, all the scripts that are necessary not only to reproduce the analysis, but also to create this homepage where all of this sits. So, two examples where how we used that, and so the idea is now that we explore a little bit more what this actually looks like in practice in a simple example. And so let's say that someone sends you, or you see something like this and say, hey, check this out. Here is some data of Costa Rica. And this is about how often people followed the recommendations during the evening, during sleep, and during wake time. And you can see it's about 15.7% of wake times that people follow personal light exposure recommendations. And you can be like, okay, I guess that's it because it says so in the table. Or you could say, well, you know, how can these numbers actually like come to be? What's the process of them being created? And so what we can do is we can follow this link to another page. And for those that want to follow it, I'm just leaving it up for a little bit. Oh, sorry, you wanted to. I'll put it up again. Here we go. So you should be brought over to another Quarto page. And if you go down to the very bottom of this page, you will find there are a few plots along the way, some analyses. But at the very end, there is exactly that table that we saw. So this figure, this is an artifact that gets produced by exactly this script. And now you can go in and, you know, go up and read up a little bit about it. Like, how did this come to be? And then you might be, hold on a moment. This is classes level data. And you know, if you followed yesterday's presentation, you know that the classes level data in Costa Rica is comparatively small because we only have 6 people. So there are 6 participants in here that produce that output table. We are actually much more interested for Costa Rica in the chest level data because there we have much more data available. So, you know, it might be okay to look at the classes level data at a bigger analysis where you have to compare everything across the same varying position. But if you singular in on Costa Rica, we really want to look at the classes level. And so it would just be nice if we could you know, go in and see for ourselves whether we can recreate these numbers and whether we can adjust the underlying analysis to actually see the classes as the chest level data. And to do that, we have to understand a little bit more about what Quarto actually is and how it works. Yeah. Oh, sorry. This one? Yeah, absolutely. So basically think about 24 hours of the day and you're collecting data every minute. And so for every minute of the day you have a light exposure level and you have a requirement or recommendation of light exposure. And so you compare, is my current recommendation, my current exposure within the recommended level, so during the day above 250, or at evening below 10, or at night below 1. And then you sum all of this up for the whole day and say, like, how often during the day was I inside the recommended range? So basically what this tells me that for these participants, overall about half of the time they were within the recommended values. And if we further decompose this, we can see that during wake time, this level was very low, so most of the time people didn't follow recommendations. During sleep, it was quite high, and in the evening, it was, you know, 2/3 of the time, so it, you know, somewhat better than the wake time. So we can see for different portions of the day, different levels of adherence, and this is not just one day and one participant, but in this case, it is across a duration of 4 weeks, which basically is like the days that were left after cleaning for the participants across the 6 participants, all summed up is then 4 weeks of data. Yeah. And because there is some times where people might have forgotten to log their sleep time, so we don't know whether you know, a person slept at this hour or not. So we have to remove these data, and also some of the data is not reliable because a person did not wear a device. You know, when they remove the device and let it on the table, those data get removed as well. So we also have to describe, you know, what portion of the time do we actually not really know whether people followed the recommendations or not. So we can see, okay, about 14% of the time we don't know what's going on. We are pretty good with the 86% of the time, and so about 10% of the time is evening time, and about 30% of the time is sleep time, and then the rest, 45%, is wake time. So that's how this table is interpreted, and we're going to try to see how we can make this better with chest level data. You're welcome. Sorry? Yeah. Well, that's exactly why we need these kinds of explanatory result scripts, so that you can go in and can see for yourself how these numbers came to be. So let me get. So basically, I mean, I did not want to go into that level of detail here actually, but so yeah, so but basically if you follow these scripts through, then you get to the point where actually these values are calculated and you can say I agree with them or I don't agree with them. We can see in this in the web page there are like additional plots where it says us like when in the day people actually adhered to the recommendations. So here we can see this number of like 15% is a little bit better explained. So there is like a little bit of a higher adherence in the morning, and then it drops off through the day. So there are additional plots that are not part of the published record, like the published table, but that are still important to understand how this comes to be. And so if we go to the GitHub repository that is linked here, we can see, you know, there are a lot of files, might be a little bit of, you know, hard to understand, but at the center are always these QMD files. And so we are not going to starting off with this document, but with a very, very simple file just to understand what a quarto document actually is, because it really is just a text file. So this here is a fully functional quarto document. It is, you know, there are colors in here, but that's just interpretation of the text. If you were to open this in a text editor, it is just very plain text. And if you let that run through the script language, then the output that gets produced is what you see here on the right. So this is just a write-up of, you know, some metadata about the document, some text, some code cell, and you can see here there is no result in here. The result is produced as it runs through the script layer, and so what you have here in the end is a document that you can send to someone else and say like, hey, look what I found out, and they not only know what you found out, but they can also click here and actually see how it comes to be. And so I've put two links here. One is to the Quarto homepage. So I mean, I'm mentioning this a lot. We are not associated with Quarto or the company that does it, POSIT, which is a public benefit company, but it is just an open source tool that we are using in order to bring the results that we are writing up in an accessible way. I want to actually go here to POSIT Cloud, which is a service that allows you to use our studio, which is one development environment in the cloud without actually installing anything. So I just let you, again on a phone it will be very hard, but just know you can always come back later to the recording and have a look at that for yourself. So I'm just seeing one more picture being taken. Sure. So let me show you. If you want to try it out for yourself right now, you do have to register, but please don't choose anything that you know, where you would have to pay money. So I'm just logging out so you can see it. So if you click on Get Started here, you can see there are different tiers. So the company offers, obviously, you know, if you're a pharmaceutical company that does the data analysis, you have to pay for these services. If you know, if you just need the basics, you don't have to pay for anything. You click on Find Out More, sign up, and then you just have to enter a few pieces of information. Or if you already have like a Google account or a GitHub account or whatever a clever account is, then you can sign up through that. So I've actually signed up through my GitHub account already, so I'm gonna log in. And you are brought to an online workspace, and we're gonna create a new project that is an RStudio project. So just leaving this open for anyone who wants to join. We're going to create a new RStudio project that will basically prepare the environment, and really this is like RStudio is a program you can download for free on your PC. So I have it here. If I open that environment while we wait for it loading in the background, you can see that's what it looks like. Might look a little bit intimidating, but really it is just a file browser, a console, and somewhere to put your script. And if we go back to the online representation, you can see it looks almost the same without the script though. So this really is the same environment you would have if you installed RStudio on your laptop, which we are not going to do because, you know, obviously with installing stuff it can also always be hiccups. So we can click on adding a new file here and add a new Quarto document. And if we do, you can give it a title. Just say create. And let me see. So what we get is one document here. It does not look the same as we saw before. That's because it's set to visual here. I'm going to set it back to source. And here's a very simple document that you always get when you create a new one. It just contains like a few example files, and RStudio is telling us that we need one package that we need to install. So we're going to install that. There's a lot of stuff happening in the background which we don't have to care about. We just have to wait for it to finish. And once we do, we can actually just create our first output here if you click on render. So it will ask us to save the file. So just give it a name, save the file. And so this will basically parse the text file through the document. It wants to open a pop-up, which I'm going to allow it. And here's the output that you're getting. So this document that we had, this code document, is parsed through, and so basically you can see the code cell here, 1 + 1, and the astonishing output is 2 of that one. But obviously, you know, the idea stays the same even if the content gets much more complicated. Oh, sorry. I have to go in here. So, you know, if you've done this, then, you know, congratulations, you are already halfway there, because that does not take a lot of complexity to get started, but it really can suck you in because you can do so much with it, like, you know, creating dashboards, and usually you don't have to start complex, but you have to start simple. You know, you can say, okay, I just want to know what happens if I add one more to this. You re-render it, you get a new output, and you can see, oh, okay, it's 3. So if we go to the Quarto page, like quarto.org, there is one example here that I showed you in the slide that contains a plot. And actually, the code over here, you can just click on the clipboard here. So if you go to quarto.org, there is one section or one tab here where you can go to R. If you just copy this little portion, go back to your environment, and then delete everything that is in there. So you're starting with a new document. You're pasting in the code example from Quarto and save it. It will tell you first of all that you require a new package that is used here that you don't have installed yet, so you have to install that one. But once you do, you can just re-render this file and see whether you can actually recreate the example that they put forward on their homepage. So it has installed now. I click render again. And if I go to the output, I can see there is the exact output that we saw before. I have these interactive code cells that I can hide or show depending on whether I'm interested in how it was actually produced. And I have, I now have an artifact that I can share with someone else. Now, it's important to mention that this HTML file that gets produced is not in itself a Quarto file. It's just an HTML file. So if you, for example, are interested in something else, like I want to send this as a Word file to someone else, you just specify a different output format. So these formats basically tell you, okay, I want to have a Word format, docx. If I click on render, it will try to download a Word file. I can open that, and I get the exact same output, but in a different format. So I've now, a more traditional summary of my analysis. Or if I want to have a PDF of it, one engine that is very nice for that is Typest, so-called. If I render it, then it will run through all of this again. So there are different layers where this data is parsed and you get a different output. And so with very little effort, so here is now a PDF page, you can you create a trace of how your results came to be from beginning to end. And when you change something in between, you let it re-render and it will always be right. So this online environment is not very powerful, so sadly we cannot recreate the whole analysis for the table, or it would run out of RAM. But what we can do is look at some portions of it. So if we go to the here we go. So if we go back to the web page here that contains the analysis script, we can see that one of the important aspects here is a package that's called Melidos data. And this is what I hinted at earlier, that we're putting a lot of effort into creating tool sets so that the data is available in a standardized form. And one of them is called Melidos data. We can install this simply by specifying it. So if I go back to the environment, just go into the console here and say install packages quote Melidos data. It will download the package and make it available for me. And so now let's go in here and say, this is now our Melidos analysis. I'm not Nora Jones. Just going to remove that, remove the date here, and I want to have HTML again. And so now I can access this package simply, through script code. Again, I don't want to make this more complicated than necessary, but the idea here is I can peek at the other script. Where is it? I can peek at the other script and see what they did. And what they did is basically load the data. And the data set is basically a variable that contains that this is classes level data, and the site is UCR because this is the UCR data set. So let's load the same data. And I'm going to purposefully write this wrong, so it's going to be like 1 minute data from chest level data, and the site is UCR. And so if I exit, I should also, first of all, call the library. So I will get an error because obviously I've misspelled this, but the package has very helpful error messages. So it suggests to me I might have meant minute here, and if I run this piece of code, I will get a data object, and if I look at that, I can see it contains all the information, the light exposure information that is used for the analysis in the Melidos dataset in a standardized form. And it wouldn't actually matter if I wanted to have it from UCR, from Munich, or from any other site. It would always be formatted in the same way because that's the way the package accesses it and gives it available to me. And we can see there are summaries in here for how the different variables are distributed, and we can now use these information to to make a summary of that. So for example, we have another package that's called LightLogR, which is an analysis package for personal light exposure data. So it facilitates the analysis of any kind of variable data in general, but specifically for light exposure. And if you go back to the analysis here, we can see that this is part of the installed packages, and it is actually used here to produce some of the plots. So all of these functions are part of the analysis package. So again, we go in here, we install a package for LightLogR. Let's install packages. We let it run for a little bit. While it does that, we can add the package to the script here, and then all I want to do is I want to copy actually this piece of code here to see whether I can get the exact same result. So can I get this plot just by copying this over? So I copy this, through the clipboard, I put it in here. You can see it has finished downloading now, and if I execute this, I will get another error in the first place. You will see why. Because it's trying to access a variable that has been assigned in the script, but which we have not yet ourselves. So we have to adjust this to UCR in this case. And if we execute that again, we can see that we get another plot. And while it does not quite look like the same because it has a different size, let's change that by adjusting the figure size. Rerun the code. And we can see that we are getting a figure that looks pretty much like what we saw in the online version, where we have traces of personal light exposure across the week for the different days, and also added the photo period, the information. And the nice thing about this context is that you can play around with this and say, like, what does this line actually do? Like if I remove it, what happens? Do I get an error or do I get a different figure? And in this case, I get the same figure, but without the information about day and night times. So I can explore these code aspects in there by recreating that. This one? So, great question. If you want to know at any point how any of these functions work, there you can basically, in the console, you can just ask a question mark, ask the sample groups function, what does it do, how does it work, and it will open a documentation page. And you can see what happens here, like what are the arguments of the function, and basically what does this n specify, which we have put 5 in here, and we can see, so it is the number of groups that we want to return, so it's the number of participants in this case. And by default, we are selecting from the top. So we could say we want to have 5 random participants, then we would have to specify that in the arguments. So the sample should be random. And if we then re-execute this, we will get 5 different participants just sampled by accident, not by accident, by random chance. So the idea really is not that I want to like go in what does this function do, what does that function do. I'm more interested in this process where you have a trace of how a figure that you might be interested in came to be, how you can reproduce it, and how you can change aspects. Now let's say that you've looked at this, you found, okay, obviously they took the wrong data set here. They really should have used the chest level data. Well, what you can do is report an issue. You can tell me I made a mistake. So if you do that, you will be brought to the GitHub repository that's underneath, and it has an issues tab. And you can create an issue and you can say, please use the chest level data. And you put out the issue, and you know I get an email, and I'm like, yeah, why not? I think that's not that bad an idea. So I can go in. I mean, I'm already logged in. You have to imagine myself, reading the email and logging in, and I can go to the script that contains all the information, and you can see the script has some information about which site and which position, varying position, the data comes from. I can edit this file. I can say, okay, this really should be chest level data. And so I'm saying changing varying position to chest level. I'm referring to the issue, and so now this file that's underneath all has been changed to the chest level data. And actually what's going to happen in the background here is that the repository will run the code. So it will run the new code that has changed, and if it doesn't error, so if I haven't like misspelled something, it will actually update the online artifact that gets produced. Now, we're not going into like how to set all of this up, although there are very good online resources. What I want to emphasize here, that this is more about transparency and flexibility, and without setting something up, you can actually create a one of these artifacts for yourself on whatever level of analysis you are in. So while this runs through, this will take a minute or two. We could watch it execute, which is not very exciting, but we will at least know when it's done. These repositories are by default open. They have to be, otherwise they will not create the accompanying online page. So while you can, upload all of these data into a private repository, the person is gone that asked about that, but so you can play around with all of this without setting anything to public. Obviously, the document that I produced here in this online version, it is not available for the world to see, right? So this is happening just on this file browser. And so if you execute this on your machine, don't be afraid that this is visible to anything. You have to actually set it up in a way that it is available for everyone. But it is very low effort to start. And I can report that Andrea, for example, has made some great analyses with Quarto and R, and like these things you have to start at some level and just go for it. So let's see if this has taken. No, this is still running through. So while that happens, I will show you like one more slide that I have here. So the analysis we were looking at now, I didn't go into details like what's happening, what is going on step by step to produce this table. This is, first of all, some of you might not be interested in that, and it's also far too detailed, but you can actually go through the analysis step by step in a live tutorial that we have created online, where you don't have to install anything again, but you can just execute individual code cells in the browser. So if you open the live tutorial here, you can see at the... Oh, I have to close this again. So you can see the page that opens basically looks the same as the one that we had before here. Where is it? So here and here. Yeah. So these two pages, tropical light exposure and health, and this page, they look almost identical, and that's because the underlying logic is the same. But the difference is here all the code is already executed and the results are already visible. In this case, you have to go in and execute the code. So you go down after everything is loaded, you can run the code, and so you can see step by step how these results come to be without actually having to install anything. So if you're interested in the more detailed underpinnings of how the of how the table is made, then you can actually run this this interactive tutorial. And you can see we are using, for the interactive tutorial, we are using the chest level data because it has just much more information available. So let's see if this has finally run. Yeah, it gives me a success. So if I go back to the online page here, we go down a little bit. Not yet. Might take a minute or two to refresh. No. Let's see if it has been deployed. Oh no, it hasn't. What's happened? Well, that's live demonstration for you. Gonna rerun the job. here we go. Okay, so now we are working with chest level data. And here we go. So now we are working not with 4 weeks of data, but with 31 weeks of data. And we can see we are not having 15% adherence anymore. We are having 23.9% adherence. So we are working with different data simply by exchanging like one word in the script, in the underlying script. And the thing is, you don't have to necessarily know how all of this comes to be. You can notice that something doesn't see right, and you report back. And if someone at the front end is actually interested in keeping this relevant, then they can go in and adjust those individual parts. But you can always go in and see for yourself, like what are the steps that a person has taken in order to get to that. And it is just, I think, a very powerful way to make the analyses that get published at the end being traceable from the very beginning. So let me see. Oh yeah, it's taking a little bit. Depending on your internet connection, you might have to rerun these. Yeah. So basically, after 30 seconds of runtime, it will tell me like this has been too much, and you have to rerun it. But you know, that's not an issue. So in the interactive tutorial, you can really go through that. So again, like this is far removed from just results presentation, but the idea here is that if we make an effort to make these steps to our results, you know, more understandable, then this can help us to, you know, to really move the field forward instead of just, you know, benefiting one single analysis. So I would invite you to try these, you know, these processes out, even though you might think I'm not going to use that, but just to see for yourself that this is not rocket science. It is very easy to create one of these documents and to play around with them a little bit, and you might find some kind of use for that afterwards. And you know, this really doesn't have to be a full-fledged analysis from the start, but it helps you understand how how other scientists have gone through the paces here. And if you find an error, well, you know, it's not the end of the world. It's basically just part of, you know, being human. I've certainly made mistakes, and if someone takes the time to go in and point them out, you know, your results will be the better for it. So, with some thoughts, I want to leave you off before answering questions, which really are that there is a worth in making this effort, because, you know, as I said before, it's like, for me it's a very personal story, because that's how I got into these processes and understood how other people worked. And I think it is, you know, this learning by doing process, starting very small, is something that that works very well in science, because not everything has to be complicated. It gets complicated very quickly, you know, if you follow through with some analyses. But if you don't start small and are able to explain to others how you did your work actually, then, you know, you might have to go back to the drawing board anyways, because, you know, if you can't explain it to others, it might not be thought out well enough. So I think that's a very strong case to invest time in these open science efforts, and to share data, to share how analysis scripts came to be. And, you know, even if you don't if you don't work in science in that way, even if you just consume this, I think there is a worth in it, just knowing that there are ways to better represent this than a data availability statement that says you can ask me if you want it. So thank you very much. So are there any questions? the question person has left already. No, but you know, depending on where you're coming from, this might look a little bit intimidating. It isn't if you approach it open-mindedly. Thank you. Sunlight is always good. Oh, and Andrea, can because there are a lot of QR codes in here, can we share the slides?
Yeah, sí, el que esté interesado,
Yeah. Yeah, yeah. So if you want to follow up, perfect.
you can send them by email and I'll share them.
Yeah.